For which n is greater than or equal to 1 is n squared plus 3n even. So we have an induction problem, which means that we're going to start with our base case, which will be when n is equal to 1. We will have 1 squared plus 3 times 1, which is equal to 4, which works out because 4 is even. So now we're going to go on to our next step where we evaluate this for, instead of n, for k, which basically means any any number, not necessarily all k, it's just a random number, and we're going to assume true. Now, if we can figure out that for any, like for k plus 1 works, then we know that it's going to work for all values, because if k works and k plus 1 works, then if we call the k case the k plus 1 case, then k minus 1 works all the way down to 1, which proves that it works for all values. So if we go and add 1 for k, we can get k squared plus 2k plus 1 plus 3k plus 3. Now, notice how I grouped these up. I could group them up and try and factor or something, but I'm going to do something a little more tricky. Basically, when we use the k plus 1 case, we have to use our k case that we assume to be true to figure out our k plus 1. So I'm going to group this as k squared plus 3k, and then also have 2k plus 4. So I'm going to group these together with these because the ones in the square is what we assumed is what we assumed to be true. So we already assumed this to be true or even. Now I just need to say that 2k plus 4 is even, which has to be true for all greater than, assume that this is integer values, or even not, because decimals can be even, which has to be true because if we multiply a number by 2, it's automatically even, and then we add 4, 4 is an even number, everything checks out. So that means that this also has to be an even number. So now we've proved that this works for all values of n. Thank you very much for watching, and goodbye.